Now in this lesson we're going to be introduced to what's known as stationary points. Now the first derivative, dy dx, describes the curve's gradient. So we need to remember that. The first derivative is a description of the curve's gradient. So if dy dx is greater than naught, in other words, if the gradient is positive, then the curve is increasing. Okay, it's going up. If dy dx is less than naught, in other words, if the gradient's negative, then the curve is decreasing, it's going down. If dy dx equals naught, if the gradient equals naught, then what we have is a stationary point. Okay, it's not increasing or it's not decreasing. And quite often with stationary points, we'll have these type. You could look one of those. That point there would be known as a maximum turning point. That point there would be a minimum turning point. And that point there, that's a stationary point, that would be known as a horizontal inflection point. Right, a few definitions here. We're going to be mainly concentrating here on finding maximum and minimum turning points. Let's have a look at this example. We need to find the coordinates of the stationary points, and once we've done that, determine their nature for the curve y equals x cubed minus 3x squared minus 9x plus 10. Well, when solving that, we'll just jot down the equation of the curve. Now, as soon as we start talking about stationary points, we need to find the derivative. So dy dx, well, the derivative of x cubed is 3x squared. Deriving that, we get minus 6x. Derivative of minus 9x is negative 9. And finally, the derivative of a constant, this time 10, is actually 0. So there's our dy dx. We can simplify that, or we can factorize. 3 is common, so we've taken the 3 out. And then the 3 there, we just leave that out the front. But the x squared minus 2x minus 3, it's a quadratic, and we can factor into two separate brackets, x and x, and we're after two numbers, of course, that multiply to give you minus 3, and the two numbers need to add to give us minus 2. So with a little bit of thought, we get minus 3 and positive 1. Very good. So at this stage, we've factorized dy dx. Now for stationary points, dy dx has to equal 0. In other words, there's our dy dx, there's our equation for dy dx, that must equal 0. So let's solve that. X minus 3 equals 0 when x equals positive 3. And if x plus 1 equals 0, then x of course will equal minus 1. So there are our x values. The question, if we look back, it says find the coordinates of the stationary points. At the moment we found the x values, so we need now to find the corresponding y values. So there are our x values. So firstly, let's do x equals 3. When x equals 3, to find the y coordinate, we need to substitute it back into the original. So we'll get y equals to 3 cubed minus 3 by 3 squared minus 9 times 3 plus 10 works out to be negative 17. So we've got x equals 3, y equals minus 17, so therefore the coordinates would be 3 minus 17. The next point of interest was when x equals minus 1. So when x equals minus 1, again, substitute back into there. We get that y is equal to all of that, and that simplifies to be 15. So again, the coordinates, x is minus 1, y is 15, so minus 1, 15 is also a stationary point. Very good. So we found the coordinates of the stationary points there. We have two of them. Next bit, determine their nature. Determine their nature. What that means is to see whether they're maximum points or minimum turning points. So we do that by checking the sign of dy dx. Now what I mean by the sign of, I mean to say whether it's going to be a positive gradient or a negative gradient. So dy dx, we're going to see whether it's positive or negative, and that'll indicate whether the curve is going up or down. So dy dx equals that. So that's why we write the sign of dy dx, and we draw a short number line there. We're interested in checking the points when around where x is 3 and x equals minus 1, so we mark them in on the number line. Then what we do is we're going to pick a number on this side of minus 1, and a good number to choose might be minus 10, because minus 10 is an easy number to work with, and we're going to substitute into that equation. And if you substitute negative 10 into that equation, you could check it out on your calculator, or you could almost do it in your head just to determine whether it's positive or negative, but you'll find you'll get a positive answer. In fact, if you chose any number to the left of minus 1 and subbed it in, you'll get a positive result. Right, moving on then. A number between minus 1 and 3. Well, the easiest number would be to choose 0. Okay, 0 is always easy to sub. So if you substitute 0 into there, this time we'll get a negative result. Then moving on, we choose a number on the right of 3, let's say 10. Okay, again, substitute 10 into there, you'll come up with a positive result this time. Now, what does it all mean? Well, what we're doing the sign of the derivative. In other words, the sign of the gradient. So, we look at minus 1. To the left of minus 1, the gradient is positive. Now, the curve must be going up. If the gradient's positive, the curve's going up. But then what happens? Well, the gradient becomes negative. In other words, the curve goes down. Okay, so you can see that point there would be a maximum. It would be a maximum turning point. Now let's consider what's happening around 3. Well, to the left of 3, on the left of 3, the gradient is negative, which means the curve is going down. And then what happens? The gradient becomes positive. If the gradient's positive, the curve goes up. So that point there would be a minimum turning point. So that's what determine the nature means. It means work it out whether it's a maximum or a minimum. Tremendous. Last step now. Okay, that maximum turning point corresponded when x was minus 1, which of course was that. So we write therefore that minus 115 is a maximum turning point, and the minimum turning point corresponded with when x was 3, which is that. So therefore 3 minus 17 is a minimum turning point. Excellent. Well, that concludes the lesson on stationary points. I'm sure you'll do very well with your worksheet.